Hey there guys, and we are back again with the third part in this design stream for this Lazy Susan phone stand. So I printed out some more parts. This is the updated, the updated version of the 623 bearing mount. You see it spins real nice there. Working out very well. I went ahead and put the bolts in here. This is the bottom half. Just for now, just to make sure that at that distance, which is about 3 millimeters, this was still clearing. They are. These bolts right up here is what I'm talking about, the top end of the bolts. So that's good. We have enough clearance here for appropriate 8 millimeter bolts is what these are, M3x8s. So with M3x8s, which is, you know, a decent size, we still have clearance for the spinner part, and then for the other cage, that drops in with spaces in between, so that's not ever going to interfere since this doesn't spin. So we're looking good there. And then I printed out the Gopro Mount, and as you can see here, I have one that doesn't work and one that does. The one that doesn't work is obviously the first one I printed, and you will recall last time I was talking about the pattern along path, and I said, oh yeah, you know, it always starts out with this, where it has this 0.5, it's a 0 to 1 scale, etc, etc, etc on the start point, and why is it not a distance? And I didn't really think about it. I should have changed that back to 0, otherwise it did half of that 1/4 inch I was trying to put in here of spacing. So I fixed that, got it mounted, and pulled out my GoPro just to confirm that everything fits. So one of the things, I've already done this obviously offline because that would be really embarrassing if it didn't work, but just so that you guys can see. Actually, let me do this first. Let me get this mounted first to the base. And there it is. Toss my bolt in here. So again, we made sure to leave ourselves clearance to put the bolt through afterwards because this is mounted on there first. And then we're going to drop this guy through. Whoops, sorry about that. That guy drops through. The spacing down here did not come out quite right, which is why this guy keeps on falling out. And why he's not actually embedded in there. One of these things, not that big of a deal. Especially because, so there's two things. One, obviously, this is a matter of print settings. My print settings with this red filament, for whatever reason, printed a little oversized since all the other captured nuts, for example, that guy, worked out just fine. So there's that one point. And then the other point, actually, that is not the correct, that is for these guys, which is why it's on my screwdriver right now. The this driver bit for the regular button head M3s, for me, is a little stripped out, so I'm just using a key. So we got that, and now I can swap over to the M5 bit and get this guy on here. Anyway, point being that I kind of neglected to finish my thought there. Point being is that you're going to put this together once in theory, and you're never going to bother opening up the base again. So it's one of those things. It doesn't necessarily matter that that's nut on the bottom is not perfectly captured. It's not actually embedded, and even if it was a problem, one of those things nothing super glue can't fix, or hot glue. Probably Elmer's glue also works. You'll also see right here, I went ahead and put that nut on the inside of the button head. I was talking about that last time. That is for if I make the little handle to do this by hand, the tightening and untightening, that will work as a hex head to give us direction to pull against. And for the record, this is an M5x30 is what I got here. The M5x20s that I have were a little short with this part right in here. They technically fit without the hex nut in there, but with the hex nut they were a little short. Technically speaking, this could be an M5x25. Unfortunately, I don't have any of those. I only have M5x30s. So there we are. The only reason it's a little off right now is, again, as you can see, it's like that, but otherwise you can see this spins just fine. So that's where we're at. Looking very good. Again, this should be a cell phone holder, not a GoPro, but that is where we're at. That's where we're going. So back into Designville. All right. Well, let's turn this analysis off. I was making a thumbnail, which is why I had the section analysis on. And we are at the end of the timeline, which is, if you were watching last episode, and you should go back and watch last episode. That was one mistake that we had, was I was not at the end of the timeline, and then I couldn't figure out why I had lost features. And we're down bottom phone mount. Yeah, this is where we're at. And let's just turn some other stuff that is in the way off. All right, 1 second. I just realized my fan's still on, so let me turn that off just in case it's messing with the microphone. Alrighty. Oh, other thing I was gonna say. 1 second. Just for reference, ends in 4 days. Actually, that said 5 days when I checked it a little while ago. So obviously, it just updated itself. So coming a little bit down to a little bit of a crunch. One of those things. 4 days isn't, a super long amount of time. So I just want to make sure we get this done as soon as possible, and then we hopefully win. So back to Fusion. All right. So this is where we're at. Right now, what we want to do is add on the connector point to the attachment. I shouldn't click that. I actually want to just turn this back on so that I can see the GoPro. And actually, we don't even need to do that really, because we know exactly how this is built. So instead of turning the GoPro on and copying features over, we'll just go, we'll just go ahead and design them in. And I will go ahead and use the center. And this is a separate entity, so I will go ahead and midplane this guy. Okay. Oh, one other modification I made, just for the record, is we didn't have on the through hole down here on the inset part for the bolt head. We didn't have an offset, so I added an offset in there to make sure that it had clearance, because on my version, on the Lazy Susan that I have right here, the bolt is actually unscrewing itself and tightening itself depending on which direction we go, the through bolt. And that is only because of this top inset right here. The bolt actually spins freely inside of the other part because I reamed it out with a screwdriver, or not a screwdriver, a drill bit rather. But because a drill bit is pointed, you can't exactly ream out a little tiny inset like this. That would require something like a flat-nosed end mill or something like that, which I do not have. At least not at 5.5 millimeter. And at least not yet, at any rate. One of those things. Maybe one day I do end up with a 5.5 millimeter square-nosed end mill. But that is not today. So we're going to hop down here, we're going to project our body, and we're throwing on those GoPro attachment points. So this is going to be an M5 bolt. We know that. We know that we want something like 3 millimeters. Actually, I think I did 2 before, so we're going to go ahead and stick with that. I'm going to go ahead and line this up with the midpoint of this. Midpoint of this flat part right here. Okay. And we'll go ahead and tangent this to that. This looks, if you are familiar with last episode, very much like what we did before. The only difference here is that I'm going to go ahead and use these points instead of going straight down. So this will have a little bit of slant on it instead. And now we're just going to, let's see, how do I want to go about this? Do I want to, because basically the GoPro mount, right? The center one, yeah, so we're going to have to offset is what we're going to have to do. And we are centered on this mount. So let's go ahead and we have the 1/8. 1/8 of an inch, 1/8 times 1 inch. And I shouldn't do that. Well, I should do that. Let me back up a little bit here, actually, because this is going to be something that comes up a lot, so I should get it just as a parameter. So use the parameters. GoPro fin thickness should be good, and this is going to be inches, and that's 1/8. All right, there we go. Now we got that set. So we can extrude this now. Click that profile, and we will offset by GoPro fin thickness divided by 2, since this center fin will have half of it on one side and half of it on the other side, and then the thickness will be GoPro fin, and that keeps everything nice and neat. And then we can just mirror this feature across the center line. Nothing too complicated here. Oh, bother me. Yeah, okay. Let's back up. Sorry about this. Yeah, one of those things you can't rearrange timelines or reassociate timelines, unfortunately. So I hopped up to phone mount to get the center line of this right, and forgot to go back into bottom phone mount. And actually, I should probably, yeah, let's do this. Okay, let's finish off. I'm gonna back up a little bit. Let's call this midplane. Basically what I'm looking at is back to just like up here where we went ahead, and let me show you the timeline here. We designed it. We designed the base feature, did a boundary fill, and then made the modifications we needed to the base feature to create the GoPro mount from the base feature. I'm going to want to do the same thing over here, which means that before I add the GoPro mount on, I really should be designing, finishing up the rest of this design here. So, what else do we need from this design? There's a couple things we could do. So this again is just as a reminder, is going to be printed laying down like this. We made sure that this angle was only a 60-degree overhang, so it's not too difficult to print. We could go ahead and, for aesthetic reasons, add some random features to this thing. So for example, we're at 3mm, so we could do up to 1.5, right? What's 1.25 look like? Yeah, 1.5. So we do 1.5 there on a fillet. We could do something like that over here too, because this doesn't necessarily need to be completely square. What are you gonna give me? 1.5, 0.7. This is not turning. I should probably click this to 1.25. How do I like that? Hey, this is just me being trying to liven it up and not have it be so square. Yeah, I guess that's alright. Sure. And actually, let's go ahead and, while we're at it, add these guys and see what that looks like. 1.3, 2.7. I'm just playing around with the numbers. 7.5, 7.9, 7.8, 9, 5. Yeah, I'm just trying to get rid of this little flat lip here. One of those things may not happen, so may as well just leave it at like 2.75 or 2.7 rather, and call it a day. And that's assuming that I actually do like what this looks like, and probably do. Nah, probably don't. Probably don't. Let's escape out of that and just leave it alone for now. Okay, so now we need to the next major thing we need to do is create the features that mesh with the top part. So A couple ways we can do that. We can have the top part sleeve onto this. On the outsides, we could create inset features. So, for example, some rails in here that it feeds onto. I just got my coffee, so I got a lot of coffee left to drink, which is why I keep on stopping. Really a question of how we want to do it. And I'm trying to think if there's any reason for any particular way of doing it. So the reason, because this is going to be printed flat, the top part will probably also be printed flat on the same plane. So like this. So let me just draw this in really quick. Flip this in. So the top part is probably going to be something like a mirror of this. And actually we probably can go ahead and just mirror this, since they're going to be the same size. And that may just be what I do right now before we add these features that I'm talking about. But let me grab that guy. So it's going to look something like this. Flat line. Like that. It's going to look something like this, and it's probably going to be printed exactly like this too, in this orientation. So all the features should be coming in this direction to keep them aligned. And they probably are best coming from the top to the bottom. One reason not to just mirror this is that we are losing a little bit. We're losing this 3 millimeters of thickness on the inside, because if you imagine the phone in here, the phone's in here, but this guy ends shorter than this guy. So if I take this line here, this guy will be down here like this, basically, because of this offset here. So we're going to have less room in the top. Now the question is whether or not that really matters, and very well may not. So the next question would be then, if it doesn't matter, is there a way to print this that we can turn it upside? And we should be able to, actually. We should be able to. So let me go ahead and start drawing it. Basically, if we draw, let's say, a slot right here and then an extrusion right here, if we rotate that 180 degrees, then the extrusion will be on this side and the slot will be on that side. But it won't work. No, I take it back. That won't work with only these two pieces, because again, the slot for the top piece will be in the back. What I'm trying to think here, what I'm playing around with, is only having this. It would be nice, it would be aesthetically pleasing if you only had to print this part twice in order to make the top and the bottom. Obviously, the attachment for the GoPro would have to be printed separately in order for that to work, and then get bolted on or something like that. I don't think that's a terrible ask. I don't know that that's necessarily that big of a deal, because then this piece right here could be universal. And if this is universal, then then again, any mounts that get printed just have to match the mounting holes down here. So it becomes a very flexible print with a minimalist style to it, which is not necessarily a bad thing. And I kind of like it. However, to get this so that we flip it over and it pieces into itself is definitely, I think it's definitely possible. I just gotta give myself a second to think about it. Right, the problem is, let's just draw it in so that we can see what we're looking at here. I'm going to go ahead and do this really quick so that we can get to the issue, so you can see the issue that I'm visualizing here, and then we can move on with our lives, because it doesn't work. So boop and boop, and these guys want to be like this, and equals to that, and centered that centered on that, and that centered on that. Okay, and then we extract that guy out, 3, and we send this guy back. This again is a rough description of the situation and not the way I would actually design it, but ideally I would like something like this, where create copy, rotate, okay fine, rotate and then create copy, axis, I want not that guy, no, we want this guy here, 180, and then modify align. That's replace. Where's my align? Nah, that's not the way we want to do it. Bodies. Let's just do this. That. Okay. And slide you up. Not faces. Bodies. Slide you up. Okay. And then I just go to slide you back 3. Alright, there we go. So this is the problem. The problem is that you can see this side lines up, and that's slotted in exactly like I was looking for alignment purposes. And this guy is on the wrong side. So the problem then becomes, we could do something like, for example, split this back and Z-shape it. So if we're looking from the top here, it could be Z-shaped, which would solve our problem, because when we flip it upside down, the Z shape then corresponds and lines up, and all of a sudden this part is in front. The problem is printing that, because again, our intention was to print it like this, and actually it would be less of a problem if we printed it like front right, this. And actually, let me go to the top view just so you can see it printing. So if this is top down on the printer, if we print it standing up like this, then actually that becomes less of an issue. We just have a little bit of overhang from the offset from the Z shape. So maybe this is how we end up doing it. The other nice thing about this is if we wanted to increase this curve, which I do not think is necessary, but if we wanted to increase this curve right here, this is no longer an overhang. This is now just parallel with the base, and therefore this can print, you know, a full circle if it needs to. Obviously that wouldn't make any sense, but the point still stands. So let's see. How do we really want to go this route, the Z-shaped route? Again, the benefits here, and it's one of those things, design is always cost versus benefits. Not always. Obviously, it has to, at the end of the day, it has to fit. It has to work. If it doesn't work, then you kind of screwed up there. But the benefits here would be that we can have these two pieces, and it's a more intuitive piece together. The downfall is that it is significantly more difficult to print the Z shape than it is to print just the flat part. The question is that really that big of a problem? Well, it kind of is. It kind of is, because it needs to be pieced together, which means that if let me go ahead and show you this right here so you can see what I'm thinking in my head. This hole right here, if I'm printed this way right here, this hole, in theory, we'd have something akin to, well, not even akin to, we would have a hole right here for the pieces to fit together. For example, we might have a hole right here, and then that would be mirrored on the other side, be a hole right here, in order for the Z shape to slide past each other. if I'm thinking about this correctly. And that all of a sudden is one big overhang. So we're probably not going with this solution, which means that we, short of making multiple pieces, we may not be printing this in, not duplicating this the way I wanted to. So let me just Control Z a whole bunch of stuff. This is probably a decent enough spot to continue from, because we need to decide what we're doing here. So that particular design, the only problem with it was that we can't just take and flip the body over and have the same print for both sides. That was our biggest problem. That is that's not that big of a deal. So yeah. All right, next question. So I'm pretty sure I'm giving up on having this one print that flips upside down. There very well may be a way of going about it that I'm just not seeing at the moment, and it may come to me later. But for the time being, we are going to abandon that, and we're going to have two separate pieces. I think, though, what I will do is, before we add these features, actually, let's add just the whole feature. We'll add just the whole feature right now, and then I'm going to boundary fill for the top phone mount. And actually, yeah. Actually, I've decided, I know I said this is probably a fine place to go, but I'm going to want some geometry on this hole rather than just the flat square that I showed you before. So we're going to go from the top because that's the easiest place to add geometry from. So we are going to do that, project that so that we have something to work off of. I'm going to do the same thing I did last time, which is center it by doing a half line here. And then the question is, what geometry do we want? Do we want a T bracket? Do we want a dovetail? This is a geometry to hold the two pieces together, as opposed to the previous geometry, which is a square, would not hold the two pieces flush against each other. It would only align them in the left, right, or X direction. It would only align them in the X direction. Let me show you that. So if you look up here at the square, it would only align them from pivoting left and right. They could still pivot forward or backward, which is the Y. So they could still pivot. The two pieces could still pivot apart like this. We want to avoid that, so we want to add some geometry coming down here through the Z axis to keep the Y axis from pivoting. So again, it's just it is largely, I think, a matter of preference here, whether I use a no, it's not actually a measure of preference, because a T slot would require overhangs. We could do a round T slot, which is not really a T slot, but just for the sake of arguments, we could do something like this. Have this be our keying feature, the feature that keys the two pieces together. And then obviously the negative of this, this prints fine. Because it's a circle, it prints relatively well with these overhangs because they're not extreme, as opposed to a T slot, which would look like this. And that obviously, that feature would have a 90-degree overhang. So this would work, but to keep things simple, I do think we will go with the dovetail. And let's see, so let me draw the dovetail out here. And do I want the dovetail? I think I do want the dovetail this way. I think that makes sense. So let's go ahead and make this 45, or not 45. Make this 45. 45. And yeah, we'll go ahead and I'm just deciding what I'm deciding now. What work you through my thought process is whether or not to have the hole start at the very back, or whether to give ourselves a little bit of a pocket right here. So imagine this just right here in between this line and the dovetail. It doesn't make terribly much of a difference, so I'm just going to go ahead and allow the dovetail to fully intersect with this line. At least I don't think it makes much of a difference. Now for the dovetail thickness, we'll go ahead and go, whoops, that is the wrong line. Let's do 5 here. And obviously, because these are 45s right here, you just do your triangle and you figure out that this is 5 plus this triangle of 45 would give us the height, which is why I can't now define this. It happens to be 11, but I cannot add a dimension to that in case you're not familiar with the mathematics of that. So there is our dovetail. So let's go ahead and extrude that down. And I will go ahead and extrude it all the way down to the floor. Okay. And now we are going to go ahead and boundary fill this into the top phone mount. And then we will add the features for the keyway. So let's create boundary fill, select our tool, select our cell. Whoops, do not select the tool twice. Select our cell, create a new component, and we will call this top phone mount. And actually, you know what I should do before I do this? There's one more feature that we're going to want in this, which is I don't know if I actually mentioned this to you. I think I did, and this may have been all the way back in episode 1, but I talked about using rubber band for the mechanism to keep it closed. Yeah, actually, I do believe that is what I said. I said there was screws or springs or whatever you could use, but basically, if you imagine on my phone, let me turn my hands around so that you can, so that it's facing the camera. So if you imagine my phone is the phone mount that we're designing right now, this rubber band pulling down on this would keep our phone in place, and then we just pull up on the top part to release our phone. So that's the mechanism for this phone mount that I'm going to be using. And I think the easiest way to implement that is going to be just putting a hole in here. Blah 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 blah. Yes. Oh boy. Top of bottom phone mount. We're gonna put a little knob for the thing to hang on, is what I was trying to say before I just went completely stupid. Why is this minus just 0? Just 0. I don't know why you want minus 68. Alright, we click this, we click the wall and that, so that we know what we're looking at. And actually, back to, I forgot to refocus here, plus I should probably add it before we add the hole in there, just so that I have a better projection. So let's click that, let's click this and that wall so that we know what we're looking at. Look at it, construction lines, turn stuff off so that we can see what we're doing. So this is our back wall, this is our 3mm thickness for our back wall. And actually, you know what? Alright, a little scatterbrained tonight, not really thinking through everything I'm doing, I'll admit. But we actually can, I got rid of it. I was going to say we can use this wall right here, this construction wall that I had before. Since I got rid of it, I'll just use the back wall. Back of bottom phone mount. Okay, I'll do it from this way instead. So I'm going to take basically the same relative projections. It's just easier to draw this way, is what happens here. So I'm going to look at it turn the body off. Construction lines. And I will go ahead and make this my knob. I'm gonna do this off at an angle right now, and we will tangent these guys. But the reason I'm putting them off at an angle right now is because I want them to be defined as perpendicular to this line instead. All right, cool. And this is going to be the knob. So how big do we want the knob? The rubber band, basically, let me grab this squiggly line, spline line. You can imagine this being the rubber band right here, going up like this. And it will be wrapped around this knob right here. So, question is how far below this knob we want it wrapped. Which, one of these things, maybe 10 millimeters might be fine. So let me go ahead and... Oh, and the other question is how thick do we want it? Looking at the rubber band, I might be comfortable with, like, for this thickness of rubber band in particular, and it's one of those things, everybody's going to have different rubber bands, so it's probably a little silly for me to be looking at it, but I'm going to say 5 millimeters here on the, you know what, 6. We'll err on the slightly larger side here. So 6 millimeters is how thick it's going to be. That's how much meat the rubber band is grabbing onto. And then, how do we want to draw this one? So, it doesn't necessarily matter because this is going to be printed down flat. So the geometry here doesn't necessarily matter. But, let's, all right, while I'm thinking about this, we're going to go ahead and square this up here. So that is now centered. And I'm going to go ahead and call these equal for right now to make my life simpler. Actually, I'm going to go ahead and delete one of these altogether because we can go ahead and design it like this and then just mirror it. So, yeah, actually, you know what? This is how I'm going to do it. I'm going to design it exactly like this and then just square this up, and then I will add the rest of the particulars that I'm looking for here as what do you call it? Solid operations. So for this distance here, my rubber band here, which is a relatively thick rubber band, relatively, obviously they make a lot thicker, but this is, whoops, dropped it. This is 6 millimeters. So we're going to go ahead and call this 7 millimeters because I plan on, I plan on adding features to this. And then back to our question of how deep on this finger we want this to sit. Actually, first, my clearance here, that's going to be that divided by half in order to get, the radius here, get this length of this segment, this chord. And then for space for getting the rubber band around it, we'll give ourselves another, 6 millimeters. Well, I'll just say, that's fine. So there's that. And now this needs to be that plus whatever depth we want this finger to be. And if I go for, you know what? 6 is my lucky number today. So there we go. So in case you're having trouble visualizing this, we're going to go ahead and clear this out. Flip that. Actually, I shouldn't do all. I should do to object rather. Do that. And then I'm going to make some minor modifications here just for aesthetic reasons. Because again, all this stuff is going to be printed flat down, so it doesn't necessarily matter. I don't have to take into consideration how it's going to impact the printing because this is going to be printed laying on this face, so it doesn't matter. And actually, looking at this, I'm realizing that we're losing space for alignment things, but we will cross that road when we get there. And then, as I was saying, we're just going to mirror this across. So I took the negative instead of actually drawing everything out so that I can mirror this. And that should be features, not faces. Okay. Alright, and there we go. So there's our little finger there, which will hold the rubber band. The rubber band can go in front or behind, I believe. I don't think there's a reason why it can't. So that is where we're at right now. Now this, yeah. So that obviously is a problem. We're going to, instead of having you there, we're going to project that right there. And then you will go ahead and you will intersect that right there. And now this is halfway in between. Now the last thing I'm going to check here is I'm going to check what this distance is here. That's 2 millimeters. I think I do want that a little beefier, so we will reduce this down to 3. And now that should be a little bit beefier. And it's 3 millimeters. The next thing I could do is I could back to this is 6 millimeters here, just arbitrarily, the distance of that shelf. So we can roll back here, or actually I called that 7. So we could call this 6, which again is the thickness of my rubber band. So now my rubber band's going to be a little curved because of the fillets I put in here, but actually we can also turn this down to 5. So we just bought ourselves a little bit more space by adjusting these variables here down. And now, if I look at this, we are now inspect that to that at nearly 4 millimeters from the edge. The last thing we could do actually is I did this at 45. We could call this 55, and let me go ahead and reference that so that it remains square. So we made those adjustments just so that we can get more meat on this thing, and we should be good. That 55, the negative of it rather, is obviously going to be a 55 overhang, but 55 is still less than 60, and therefore I'm still plenty comfortable with that. So that brings us back to making this boundary fill. And actually I activated the wrong component. So that's our boundary fill for the top mount. And I am now going to go ahead and align this top mount the way I want it oriented. So we'll do that. And do that. Turn you back on. Flip you. And actually no. Not you. Turn you back off so that I don't actually click you. There we go. That's what I wanted. Yep. Okay, cool. So now the front of the top mount is aligned with the back of the bottom mount. Let me just turn this midplane off so that it stops being annoying. And now we can go ahead and there's a couple different things we can do. I will actually align this by turning the bottom off and then aligning. So instead of move copying, I will turn the bottom one off and align the inside here to the top of the bottom mount. And then flip it. Oh, it's not going to flip in that direction, and it's not giving me the angle button. So this is less efficient than just rotating this 180 degrees. So let's just rotate it 180 degrees. Change it to components this time. Rotate. And I guess it wasn't necessarily less efficient. I probably shouldn't say that. So modify, because now I've got to realign this. That to that. Alright, stop being obnoxious. Oh, that's not the center line because we have this feature offsetting it. So, I really did this in a roundabout way, I gotta admit. There was definitely a faster way of aligning this. It's one of those things. Okay, lost a little bit of time, no big deal. And component, do this. Bottom, do this. Okay. Alright. And bothers. Okay. No big deal. No big deal. I still had in my head that we'd take this and flip this over. We are going to fix this now. Slide these past here. And evidently the alignment got screwed up when that happened, unfortunately. Let's go ahead and fix the alignment. So turn the bottom guy off. Alright, we're just going to delete alignment for right now and redo it. Alright, so we are going to align that face to that face. Okay. And we are selected on components. Modify, align that. And that is, nope, not that one. That is the bottom guy. I want to align the top guy. Top guy to the bottom guy. And then flip ya. And again, I did this backwards. I should have done that first and then aligned this to that and flipped it. Oh, it's gonna rotate me anyway. Alright, cool. Whichever's. Let's just rotate you like we did before. No big deal. Select, rotate, 180, modify, align. Okay. Again, doing this in the most... Actually, I can leave it just like that because we are going to introduce whatchamacallits. Joints. So it doesn't actually matter that's all the way up there. So since I've got to change this, we are going to go ahead and mirror this. Again, previously it was in my brain that we were going to be able to flip this, and we decided that we couldn't. So this is now the state of things. This now has two dovetails, and we'll go to the top and create the matching dovetails. And actually, is this gonna work? It's not. So I'm gonna change how I'm doing this. Okay. To keep things simpler, we are not going to do it this way. We are instead going to actually get these aligned the way I wanted them aligned. Modify, align, that and that, all the way down here. Okay, capture. And we are going to draw the dovetails and then cut. Again, 1.5 million ways to skin the cat, but this way is a little bit cleaner. Turn the bottom guy off because we don't need them. Turn the actually turn that whole entire stack off. Project. Okay. Look at. And remembering what I did before, it was 3 and 55. Delete that guy. Just putting everything back to the way I found it. That. This is 55. This is a copy of the 55. And then we just align this. Well, let's draw that line in instead. Oh, I do need, turn the body back on. I do need this wall right here. Or that edge, I should call it. That edge right there. Because, again, we changed our line to be there. And then we midpointed that on that line. And we called this 3 millimeters. And this guy to there is also 3 millimeters. This is the thickness of our back wall on the cutout. So that is how we got back to this. This should be the same exact shape that we just created. I'll go ahead and extrude it all the way down. It's not really necessary to extrude it all the way down, but we're going to do it anyway. It's not necessarily to extrude it all the way down because there's only just so much alignment that's necessary in order to keep the phone stable. Keep the phone holder stable, rather. Somebody's really upset with himself. I'm sorry. I'll tell you, I'll be real with you here. Somebody was really excited because we have 4 days left. Well, I thought it was 5 days, and I knew that this was the end of day 5. Somebody was really excited to get this thing done as quickly as possible, and therefore he's rushing a bit. So, one of those things, rushing tends to make mistakes, as everybody knows, and we are running into all those mistakes right now. So, I apologize. Please do bear with me. Good, that is parallel this time, and that is parallel this time. Fortunately, it doesn't take terribly long to fix these mistakes. Unfortunately, we are making mistakes. And it does take a non-zero amount of time. So, eventually we'll have this done, and hopefully we'll win the contest. I did not just lock that, did I? Good. Alright. Boink. And extrude. And you know what I should say? Hopefully win. I said hopefully we win the contest. Not for, you know, anything in particular, but just because you should always try to win. So it's not like I'm going to be super depressed if we don't win. I just want to make sure that we are, or I am, at any rate, maintaining focus here and doing the best we can in order to maximize the chances of winning, because when you maximize the chances of winning, you do a better product. So that is why it is important to attempt to win, even if you're not going to be terribly sad if you don't win, because you really enjoy the experience of doing these design streams. There you go. Turn you back on. Activate you. Combine. Bottom with top. And we will cut. And we'll keep tools. And then we will add offsets in order to add some, what do you call it? Add some leeway for the 3D printing. And again, I'm just going to go with a big offset here. Normally I do 0.05. Actually, probably 1.5. It's because I don't want it to be super duper loose, but I do want it to be easily slidable, so I'm going to go 0.15 there. Again, looking at this, I just want to double check that. So that looks like that's fine. It probably will be the minimum distance. Alright, I don't see a minimum distance there. Let's try the edges instead. Okay, that's 4 millimeters thick there, so that's not that big of a deal. And the edges we already looked at, and the edges weren't bad. So, I think we are groovy at this point. Oh, we are not groovy. I take it back. I take it back. We are not groovy. Are we just... Yeah, I think we just put a cutout there is all we do. So let us hop back over here. Actually, no, back before we do the boundary fill. Control Z. Control Z, please. All right, there we go. All right, so back before we do the boundary fill, in case you did not notice, our rubber band can't get from one side to the other right now, which is a little bit of a problem. So what we want to do is add a notch so that at this closed, and actually let me do this first, just to demonstrate why it only matters when the is completely closed. Mid-plane, bottom of top mount. Okay. And we're going to add as built joint, that, and that's going to be a slider, and it's going to slide. We can just call it, yeah, let's just use that edge as the reference point. There we go. Cool. And we will, while we're here, we'll edit joint limits. Okay, or not. Edit joint limits, minimum, maximum, and which one's positive? That one's positive. All right, cool. As expected. So at the very highest, which let's say is this, it's 60 millimeters. At this very highest, when this is as extended as we're going to allow it to be, you can see that this can reach up until this point right here, which we're, okay, I'll call it 15, maybe 16 millimeters. We can still reach, but all of a sudden we start going down, and now this needs to be cut out in order to reach that little finger there, the little hook, the little knob, whatever you want to call it. So that's what we're going to do. And again, we go back before the boundary fill. We will highlight the bottom mount so that we have it on this timeline. And then all we got to do is add, it's probably honestly the same height that we have here. So let me just look at what this height is. So 14 it's probably 15 then. And actually that makes sense because I called it 15, 16, right? Was our minimum distance. So 16 would be 15, 14 plus 16. I have no idea where that comes from. But, or why that's 30 is what I should say. But regardless, chances are that my intuition here is more or less correct. And again, so long as it works, it works. So just using this back plane, we'll go ahead and highlight this to get our projections and throw this notch in here. And this notch doesn't have to be anything fancy because all it is clearance for the rubber band. We will go ahead and let it be the same size as this. And we said this was, I'm going to call it 15. Finish, extrude it. And just in case something happens, I'll just do the 2 object like I did on the bottom. And we will just add in some fillets, again, just for aesthetic purposes. Because it will be printing on this face, it doesn't necessarily matter. Cool. And since we added that there, and I went ahead and did these top corners too, I will go ahead and round out these guys as well to keep that whole entire edge round. And now when we do the boundary fill, hop up the, not that one, phone mount. Hop up the phone mount. The top shell should have this updated on it as well. I'm pretty sure I just clicked that. There we go. So now we are clear, and you can see, bam, easy peasy. The rubber band can fit right around here at the minimum distance. And that is the phone mount effectively done. The last thing we will do is boundary fill, as I talked about at the very beginning of this, this episode. We are going to make the GoPro specific version. New component, okay. And we activate GoPro bottom phone mount, okay. And now we can come back in here. We will turn everything else off and take our mid plane Attempt to... Oh, I'm on tangent plane, that's why. Not mid-plane. Mid-plane that up, so we get the center line to work off of. And you guys should recall the way we did this at the beginning of the stream, and the way we are... we've done it basically on the bottom part. It's the same exact process. We just determine what the holes are, and then what distance the holes need to be, and add some connecting points. There's that. There's that. We make sure that these are tangent because that's more aesthetically pleasing. This is a 5mm hole. Or actually, this one is not 5mm. Because I added those connected points to it, that's the walls. So this is 5mm, and those walls are 2mm, is what we had decided. And because we, as far as I can think, don't need any particular clearance here, we can go ahead and do that. And I'm going to toss this on here, make that perpendicular, and make that point centered. So now the hole is directly below the center point of the flat part on the GoPro, or on the bottom phone mount. We go ahead and extrude this out like we did before. Again, we're going to offset by half of GoPro. Oh, whoopsies. You may recall that I hit Control Z a whole bunch of times, which means that our parameter is no longer in here. GoPro fin thick, and we decided that that was 1/8 of an inch. Finish. Extrude. Turn the bodies back on. And I'm just double checking that I'm not being silly here. So our offset is half of the fin because the center fin we do not have. This is going to go either side of the center fin. So GoPro fin thick divided by 2. And then GoPro fin thick. And we join, and then we mirror. Mirror. This feature, try again. Off of our center plane. Okay. And there we have it. So that is that completed. And we can also go ahead and throw a joint in here. I don't think this is going to be a problem. I actually don't recall ever doing this before. It really shouldn't. I'm sitting here talking and blabbing, and it really should not. I'm going to change, however, and say this guy just so that I don't get confused here on these joints. Okay. And we can edit joint limits and call that 0 and 60. Okay. And then we can turn this on. Turn the attachment plate on with the GoPro mount is on. Yes. And we can go ahead and line this up. Modify, align. This guy to that guy. And I was trying to get the center of the hole, but I think we should be fine. Yeah, it looks like we're fine there. So there is that. We can capture position because I'm not doing anything else there. The last thing we can do is add another joint in here for funsies between that guy and that guy. And this will be a revolving joint. And we can just pick the center fin here and the center of the center fin. And then again, if we want to add some joint limits in here, minimum, maximum, I'll just go ahead and drag them out. This is the minimum, right? So the minimum, I'll say, oh, okay, that's right. Well, it's important I looked at this. Obviously, that distance there does not match our distance over there, so we're gonna have to fix that. But let's say, because these fins are in the way, and actually we're technically facing the wrong way here, but it's one of those things. You and I are gonna be the only people that notice. There's minimum. Call this, I don't know. These minimum maximums on this guy, this is all just gravy, but we do have to come back in here and fix this. So let's look at the GoPro mount really quick, just so that we know what we're looking at and I'm not just guessing. Not that guy, that guy. So if we look at this, this is 8 inches up, and this is 2 millimeters diameter off of this hex nut is the big problem. This is 2 millimeters diameter off of the hex nut. Technically this 8 inches here, or this 8 millimeters here, doesn't necessarily matter. So to keep things kosher, I'm going to just draw a hex nut in and then do the 2 millimeters off of that on the bottom phone mount here. So let's go ahead and draw this guy in here. And I forgot to grab the size of the hex nut because I only really memorized M3 nuts because I use them all the time. This hex nut size is 7.8. All right, here we are. 7.8. And then we will take, let me take you out of the way for just a moment, please. So that's 7.8. This guy is the guy I'm referencing off of. And now you can see that I have this like this, right? And obviously this is a bit of a problem. So what I'm going to do here, and if you don't see why it's a bit of a problem, chances are, I'm guessing, if I project this wall right here, I'm guessing we're over, yeah, so that says 179.1, so that's not 180 degrees, which means that it's not a straight line, it's not collinear, and that is a problem. So I'm deleting the center point, so now this whole entire thing can shift left and right. I'm going to delete this leg for actually, rather than delete that leg, I'm just going to uncouple it from there. Okay, never mind, that was not the correct one. Uncouple it from there. There we go. And just hang it out over here. I'm now going to take this guy because we're printing flat on this side, so we need to make sure that this is minimum here. And then I will go ahead and project this, not that face. You silly face. Turn the GoPro off. Attachment plate. Project that face, okay? And we will go ahead and connect that to that face. So it's going to look a little bit different, but that's okay. And then, just for the heck of it, this again is only just for me to get my sizing, this hex thing right here. But just so that it doesn't look so obnoxious to me, I'm going to go ahead and make it parallel to there. And then we're going to go ahead and make this the 2 millimeters. And then we can decide how we want this. So there's a couple ways we can do it. One, we can decide on an angle that we want it at. 2, we can decide it at a length. Or 3, we can just call it parallel. Well, parallel is actually still angle. I was thinking angle relative to this. So for example, if we wanted it going, let's say more or less like that, so it's getting very close to tangent to this line, that is an option. The other angle that makes sense is having it parallel to this guy. That also makes sense. And honestly, I think that's what I'm going to go with. So that solves our problems here. Or at least should solve our problems here, I should say. Just going to have to fix that because we lost the hole there. And then if we turn the attachment plate back on, or turn it on rather, not focus it, we are now... Okay, so now all we got to do is fix this alignment here. There's that alignment. We will adjust that alignment so that that is like that. Okay. And that is now aligned. So last thing we can do, you can see how that's extremely close, and in fact it's tangent too. We can fix that pretty easily by let me just look at the bottom here. Okay, yeah, we do have space on the bottom there because that is 8 millimeters. But let me just hop over here so you can see what I'm talking about. So 2 ways to fix it. One is to just up this to 3, which will push it further out. That's fine. The other option, as you can see, in case you can't see, that extra 1 millimeter got added up here, let's say in line with this, to this part of the radius, which push the hole down effectively. So that's one way to do it. The other way is to, instead of making this tangent, drag this down, add another line like we did before, or actually we don't even need to add another line. We can go ahead and do, you know, for example, 8 millimeters. I'm going to make this 7 instead, because again, we only need just a little bit. And now, and yeah, I will just have to realign this because it doesn't know how to realign itself. Realign, okay, and there you go. Whoops, I clicked the wrong thing. Realign that to that. There we go. And there we go. So now we got a little bit of upset here, a little bit of offset rather, to give us clearance. So we go ahead and spin this, and that is looking groovy there. We go ahead and spin this way, and it starts freaking out. Careful, careful. All right, there we go. So, yep, that's what it is. And again, technically speaking, this is backwards on here, but I am not particularly concerned. Technically, my suggestion would be to turn this around when you actually install it on the Lazy Susan, so that the phone is over top of the center line. You can see here the phone is over top of this offset point. At least the bulk of the phone will be. The phone, in theory, if it's pushed all the way back against this wall, will always be over top of this. The back of the phone will be, but the center point of the phone is more like to the right of it, which means that if you spin this around, it will be closer to the center line. So yeah, one thing I will do really quick before we move on to the very last thing that I want to do, because we are more or less done here, and I'm very excited. I want to make a custom foot for this thing, or a custom feet, however you want to refer to it as. But before we do that, let's just get some more colors in here. So let me turn the base on. So we've got, where do we use purple? Do we use purple for something? It says that I've used it in this design, but I don't see it. So I'm going to use purple there. And I don't recall using green either. So I'm going to put that up there. Let me hop in here because evidently I'm guessing... Oh, okay, the airsofts and the airsofts are green now that I'm remembering. Let me turn those on. And let's turn those actually. There should be a transparent green plastic if I recall correctly. Transparent. Translucent. There we go. Translucent. We're going to make you translucent green instead because the airsoft BBs actually are translucent green. So now we have a slightly different green for the BBs. And then I'm not sure. Select objects applied to. Okay, one of the rings is purple. Not particularly concerned. So let's hop back up here. Look at our masterpiece. Yay. Again, that's technically backwards, but don't tell anybody. I'll fix that on offline because it actually does, looking at it, bother me immensely. But we are almost done. Just got to add the feet now. So I'm just going to collapse a bunch of this to organize. And then we can add the feet. And actually, before I name this, let me show you what we're doing for the feet, because I don't think I've showed you before. I have, from another project, a bunch of suction cups. So these are 30 millimeter suction cups. I do have the design in Fusion already. So let me go ahead and open up this panel and import it. And actually, before I do that, let me make that component like I was talking about. Suction cup feet, actually. Feet mount I'll do first, because again, like the top mount where we boundary filled the base feature, I'll do that again. But just really quick to get us set up, suction cup feet. Okay, and then insert the suction cups, which should be in this folder. Suction cups, there we go. And I did just model them today, even though I technically used them in another design, because I didn't actually model them in the other design. I just took the measurements off them and then incorporated them that way. Insert into current design. Again, I would love to be able to break this, but it won't let me, unfortunately, and I'm just moving it out of the way here. Right. Oh, will it let me break link this time? Break link. Okay, cool. It let me break a link. I seem to recall on one of our other designs, it wouldn't let me break the link. But it seems that our problem is now solved. So let's go ahead, and the base should have, the bottom shell should have a bottom of bottom shell construction. Okay, it does not. So let's add that really quick. Okay. Bottom of floor. And then we can hop back into the feet mount. And that was not the bottom of floor construction plane. There we go. And now we can project that guy. And then we can turn everything off because we don't need it anymore. Off, off. And we'll turn the suction feet off for now. And we look at it. And we are not facing front. Not that it necessarily matters, but now we are. Right? Oh no, that was front. I take it back. Okay, fine. So we need that guy. We need that guy. My personal opinion is that we do not need this guy because in theory this hex nut is in there inside that capture. So we never actually need to get to it. What we could do, just to be nice, is we could throw the 3mm through bolt in here so that it can pass through, because our feet in theory will pick the bottom of the Lazy Susan up off the ground, which gives us clearance to use a slightly longer bolt if that's what we have. Alright, and then just like we did on the other one, I'm going to go ahead and do the center slots. Again, just mimicking what we had before. And the radius here, 3 is fine. And then we can just extrude this out. I don't need that just yet. 3mm, wall thickness. Okay. And let's get a color on it. Alright, I think I'm going to make a new color. So let us, what color do we want? These are all the colors we've used: red, orange, yellow, blue, green, indigo, violet, black. Actually, we haven't used black yet in the design, it doesn't look like. So I can actually just grab, isn't there a black plastic? Is there not a black plastic? Opaque. There it is. Black plastic. I knew there was black plastic. There we go. This is now black. Black is harder to see, which is why I've been trying to stop printing in black when I do these design streams and show you the finished product. Sorry. My bad. Alright. So that is our base feature. And now we will go ahead and suction cup. Boundary fill that guy, select that guy, and make that a new body. And now we can turn the old body off. This is now gray. If you had a hard time seeing the black, you're welcome. And now we just need, let's see. I guess what I really want is I need to double make sure this. So 2.8, 5.6, 5.6 is my diameter. So let's go ahead and toss this on here. Toss a sketch on, project that, and then we need to basically account for these suction feet and make sure that they're not interfering with each other. So I know that it's a 30mm suction, whatever you call it. So we need to at least account for that. throw in a line to align this with. And then, so that's there. This guy was 5.6, right? Or was it 5.6? I've already forgotten. Let's check. Inspect. 5.6, good. I'm not going insane. Only slightly. So there's our 5.6. This guy, it's one of those things. Let's look at how it looks in comparison to the base. And actually, it would be useful to reuse this base size and just align it with that edge of that base, or have it sticking out like this. So I'm going to go ahead and align it with the edge of that base, tangent to there. And the reason I'm doing this is now one edge of this suction cup is easier to get to in case it gets really well stuck to the counter, whatever you got it attached to. So you can get in there with a knife, a fork, whatever you have, if it's the kitchen, you know, to pry that suction hook up to break the suction. So that's why I've decided to design it like this. Otherwise, it's one of those things. The next question is what we exactly want this to look like to get to this 5.6 part. Actually, I take it back. The other thing that we need to consider is that the suction cup, let me pull the suction cup back up, needs this much space. It needs a gap in there. So let me just get that really quick. Yes, I did this morning. No, I do not remember what it is. All right, 3.5. 3.5 is what it is. So we need to leave about 4 millimeters, let's say, of space between this plastic piece right here. Well, I shouldn't say this plastic piece. Between the base and the bottom of this suction cup lid, which means that wherever this plastic piece connects to the center of this right here, because that's how you generally attach suction cups, you put a little cup in there and then, or not a cup, but a little concave in there and then slide the suction cup onto it. Point being, we need to leave about 4 millimeters there, which is an important thing to remember. And then, how are we printing this is the next question. So this 3 millimeter thickness right here, it may end up being thicker just to make it easier to print. Because, again, if the concave where this little tab is going to be sitting is on the top side of this, then this actually becomes easier to print upside down, just like we printed these wheels up here. If you're looking inside of the base here, let me turn the top and bottom shell off, well, bottom shell body I should say off. This 623 bearing wheel that I put on here, we printed this guy upside down relative to its orientation inside, inside of the base. So in the same manner, we may end up printing this upside down, and then we just extend this center part down to make it all level so that we don't have any overhangs when we're printing it. Which all sounds good to me. So let us go ahead and do that. Last thing we need to do is just decide, as I said before, I started to say, and then we got I tangented us onto that design discussion, just the shape of what this is. So you recall last time I just randomly made an arc when we were doing the mount for the GoPro thing. I just randomly made an arc and said, okay, it's good. This time I think I'm going to go ahead and just give us our wall thickness here, and then the only question is, so obviously I can make us tangent here. The question would be whether or not I want to do like tangent here and then curve it down. So let's say we do this, okay? And then I call this something like, let me get that angle, call this something like 150, okay? And then after I extrude this, so basically it gives us something of a curve, and I can even out that curve a little bit more with the fillet tool, or again, I can come in here with the spline tool and throw a spline in here, make this tangent, there we go. And then, adjust these variables here for the look of it. There's a bunch of different ways. I'm just throwing them out there because this is a design stream, and therefore it's worth discussing. The other way, actually, other option is to go tangent to this guy. Let me turn the body off just so I make sure I'm not clicking anything I'm not supposed to, because sometimes Fusion grabs the edge of the body instead of a sketch profile. So we can throw tangent here, and then we have this large body right here. It's a large diamond-shaped body. Aesthetically speaking, that's not really that bad. The one thing I don't particularly like about going from, for example, this point and doing an arc is that it does break up the flow of this, whereas with how I'm doing this right now, we don't actually break up that flow. So let's go ahead and stick with that. I've actually decided that that is what I like. So we will go ahead and go with it. And again, as always, I'm just going to mirror this over. And the next thing to say is that we probably shouldn't extrude this right now. So even though I just drew that at this point, what I will do, and let me just grab my bearings really quick. That's top, that's bottom. Okay. So this is 3 millimeters here. I will extrude this out another 4 millimeters because that's what we need for clearance. And then I will go ahead and extrude this from that point and extrude it up wall thickness. And now we have our full 4 millimeter clearance here. The last thing I need to do is, again, the suction cup is going to want to piece into here. So we may as well draw that right now on this sketch. Two ways of doing it. One, we can go ahead and draw. I'll just draw it really quick like this. Draw in a section right here for it to squeeze through on the edge and just say, look, the suction cups are going to be opposing each other, so you'll never actually be able to slide the Lazy Susan off of one suction cup because the other one will prevent it from moving. In theory, technically not true, but in theory it should not happen. Not true because one of them can slip while the other one remains stationary because it's a suction cup and it's not perfect. That is the simplest way to do it. The next intuitive way to do it, I'm not saying intuitive as in it is the most intuitive way, but to draw a larger section for the head to pop through here, and then to connect this down here and make a keyway. That's what we're doing here. We're making a keyway. So we make a keyway slot here, and now there's no way. Well, I shouldn't. Again, technically speaking, the one suction cups can slide and it can slide off. However, it is not likely for the suction cup, it is less likely, I should say, for the suction cup to fall out while you're moving this thing around, while you're carrying it around to a different location with this keyway design. So I think that is what we will end up doing. The only thing I'm going to need to do is determine what this radius is here, this largest point radius. And as it turns out, that is 10.3. So we make this 10.3. Give me my home view back. There we go. It looks like I have two lines here. Do I have two lines here? I do have two lines here. All right. So we go here, and so long as this is tangent, this will be the same size as the 5.6. So we just make this parallel. And that guy, I'm going to change him from being just arbitrary horizontal, vertical, to being perpendicular to that guy. And then this guy just needs to be tangent to that. So the distance between these two, because they're tangent to this circle, is 5.6, so that's good. 5.6, so long as we do not offset this, will be a little snug when we're 3D printing, because 3D printing tends to be a little, well, in my experience, holes in 3D printing tends to be a little bit under extruded, or a little bit smaller than expected. The next thing that we decide here is how long we want this intermediary section to be. So the head comes up through here, and then we start sliding, and then you have a little gap here. Actually, the other thing we could do is we could make this slightly smaller, this keyway slightly smaller than this actual hole right here. And that would just give us a little bit of pinch while going through it too. It's probably not necessary. I'm probably just overthinking things. So let us go ahead, and I'm just going to arbitrarily call this 5. No particular reason. I can't think of a good reason to make it any specific number, because all it is a keyhole. One of those things, heck, the keyhole could be overlapping a little bit and it wouldn't be that big of a deal, strictly speaking. So, like, for example, just so that you can see what I'm talking about here, we technically speaking could do this. We could have the keyhole sitting like this, and then just these two circles cut out. Don't cut out these. Let me just turn them to construction lines really quick so that you can see. So we're only extruding these areas here through as holes, and then basically the head comes through here, and then it's got a little bit of a pinch on these corners to keep it from popping out, because again, this 5.6 will be slightly under extruded in my experience. One of those things, if I go ahead and print it and it ends up being too loose, we can always come back in here and call this 5.5, 5.4, you know. One of those things, it doesn't change anything terribly much. And that would make it a little bit tighter, but the point being is that actually, you know, this distance here between, let me toss this here, and then connect them. We've got a pitch point here, which is less than the diameter of this 5.4. So this flexible plastic can squeeze. I'm just going to pop you back over to the camera. This flexible plastic in the middle can squeeze in through gaps. So the fact that it's a little bit smaller, specifically, grab our inspect tool, 3.6 instead of 5. Or actually, let me change this back to 5.6 for the sake of the argument. So 3.8-ish, you know, so it's a full 0.8, 1.8. It's a full 1.8 smaller, 1.8 millimeter smaller gap to get through. It probably can flex that much and to squeeze through that gap. And it's one of those things, if we needed that gap a little bit bigger, we just slide this a little further up. And you can see how that gap gets bigger as we go. So that's the other way to design it. I'm going to back us up here. Instead, I'm going to go ahead and leave it like this and call it good. So let's go ahead and finish this sketch. Make sure that's the good extrusion. I'm going to back you up. And then we will go ahead and get rid of these sections right here. And we're going to call that correct. Now I'm going to go ahead and modify align that with that. Okay, and rather than fiddle with those numbers right there, I'm just going to go ahead and align down like that. Okay, and capture position. And then we can go ahead and mirror features. We're just going to mirror this across. I don't have a midplane yet, so back before we add this feature, I'm going to go ahead and introduce a midplane, because I know these sides are still centered at this point in the timeline. So let's go ahead and mirror that now. Mirror, feature, that, and that. Okay. And it looks like we lost our alignment. There we go. Let's hop back in here and mirror that body, or that component rather. Mirror the suction cup across there. Okay. And then we can turn this mid plane off. Top of mount. Okay. So again, this gets printed in this orientation. And so this gap that I have in here, I just called this wall thickness for this extrusion. This gap is technically, let me double check really quick, 3.2. So we're gonna have a little bit of gap for the up and down wobble. I don't know it's that big of a deal. Again, I'll print these out and I'll test them, but I think we're just doing just fine. So the last thing that I want to do here is countersink the holes. Actually, there's two things I want to do. One, I want to make a rigid group here, and we will go ahead and include child components for right now because I don't anticipate adding anything else to this group, which would make me paranoid. But the last thing that we will go ahead and do is, I don't have a bottom, do I? That's the top. Nope. All right. We're going to countersink these holes for the bolt heads. For the M3s. And we're 5.5. Just make you equal. And then 2.5. It's technically more like 2.3, but 2.5 is fine. Obviously, the 5.5 is going to put us a little closer to this edge than I normally like, 1.75 instead of 2 millimeters that I've been, that I've been compromising with. A lot of the design has been 2 millimeters edge wall thickness instead of the 3 that I keep on telling you I like. And that 2 millimeters again is a compromise. This 1.7, one of those things, it is easy enough to fix. For example, all of our mounts probably should have this, in which case I should be able to just come up here to feet mount and change this to 4. And then everything else should update automatically and we shouldn't run into any problems, especially because these suction cups are perpendicular to the changes we made. The changes we made affect this distance here. It doesn't really affect this distance here, not in a meaningful way at any rate. So we should be good on that one then. And let's make this white plastic to round it out. Glossy, matte, matte. There we go. So that is the design totally and completely done. So the only thing I have to do at this point, whoops. And actually, one more thing. As built joint, that to that, solid or rigid, okay. All right. Actually, let me make sure I clicked the correct bottom shell and specifically the feet mount instead of the suction cup feet mount. There we go. So now that's rigid, and let me go ahead and just turn you off because you're not really relevant. All right, so yeah, that is this design done, polished. All I got to do is make the video to go with the upload on Thingiverse. And well, actually I won't upload to Thingiverse just yet. I don't think. I think I will make it exclusively printables, since it is a printables Prusa contest. I'll go ahead and keep it just Prusa only for right now. So yeah, just turn this around, make the video, and upload the designs to Prusa. So for anybody who's following this, for anybody who watches in the future, I hope you've enjoyed this design stream, 3-part design stream. Our I can't remember video stream 1 whether or not that was 1 hour flat. It may very well have been 1 hour flat because all I did was just design this Lazy Susan, which was pretty straightforward. But the last 2 streams have been slightly longer than my 1-hour streams that I normally shoot for. One of those things, so long as you're cool with this, going up towards the 2-hour mark, I don't particularly mind doing about 2 hours worth of streaming. Although, since I stream at 8 p.m. EST, I do get a little less coherent after 9, but that is something that will change with time and not really be that big of a deal in the future, I don't think. So yeah, give me feedback if you don't mind it being a 2-hour stream. And otherwise, thank you for being here. Thank you for following along. If you just found this, thank you for finding it. That's really encouraging. And as always, have a great and wonderful day, afternoon, or evening, wherever you're in the world. And I will catch you next time.